and this is my partner Arthur Sopolo, and we built a Sumo robot that is called the Fortress because it was a fortress. Our robot had, what our robot had to do was autonomously push other robots out of a circle while at the same time trying to avoid being pushed out of a circle without being remotely controlled all automatically. So our constraints were not allowed to use more than 3 servo motors, 2 ultrasonic sensors, 1 light sensor, 2 touch sensors. We weren't allowed to have more than 4 total sensors because that's the limit that an NXT can't fit more than 4 sensors into it. We weren't allowed to have more than 1 NXT, and it wasn't allowed to be more than 3 pounds and 13 inches by 13 inches.
Some of the features and benefits of our robot included 2 separate motors to allow the robot to turn right and left, a short, wide, and flat wheels for high traction, and so it wouldn't be able to be knocked over easily. A moving plow in front that moved up and down, that could push robots and move them up to lift the wheels off the ground, and different sized gears to create torque so that our robot couldn't be pushed and it would be the one pushing.
Yeah, a gear connected to the motor that was small, which turned a gear connected to the wheels that was large, caused it to lose speed, but it gained torque.
Some more features and benefits include a light sensor facing down so it could detect the white line, shields on both sides and a little bit on the back to cover the wheels so that an enemy robot couldn't get underneath and lift it up, an ultrasonic sensor to detect opposing robots and move towards them.
Some pros and cons of a robot were the weight and low center of gravity of a robot in the design made it very difficult for it to be pushed around, and especially for it to be flipped over, because a low center of gravity means that, and the fact that it's very heavy makes it very difficult to be flipped over. And the plow on the front is very good at pushing other robots out of the ring. However, it moves very slowly, which is what we had to sacrifice speed to get the amount of torque we had, and the fact that it was really heavy slowed it down. The wheels slipped very easily, which made it sometimes get pushed out of the ring because of that. And it didn't always detect the edge of the circle, and the light sensor didn't always cause the robot to reverse, because for some reason programming had maybe a bug in it or something that didn't allow it to detect the line all the time.
Some problems included that the initial forklift we built was not strong enough to lift up other robots. So we solved this by getting rid of the forklift and turning it into a plow that could lift up other robots that way. The gears between the motor and the plow kept slipping away from each other so that wheel no longer could drive the robot. So we removed the gears and just made it a direct connection to the motor so that nothing could go wrong with the gears. And our robot was too slow, so we reduced the torque and made the gear ratio less so that it could be faster.
This is our program. The first thing the robot does as soon as the match starts is it moves, because the robots, at the beginning of the match, the robots are back to back, so the first thing it does is it moves forward for a very short time, about 2 seconds I think, so to get away from the opposing robot, and then the main program starts. This is the main branch of the program. First, it looks at the light sensor. If the light sensor does detect something, then this part is ignored, it goes here, and this part is ignored. If the light sensor does not detect something, it goes here and looks at the ultrasonic sensor. If the ultrasonic sensor does see something, it moves forward to try and plow the opposing robot out of the ring. And if it doesn't see something, the motor is turning opposite directions, so it turns until it sees something. The next branch of this is it's parallel processing. So while the other part of while the other branch is running, this branch is running too. So the light sensor is continuously checking. And if the light sensor detects light, like the tape at the edge of the circle, it turns to make sure that it doesn't get pushed out of the circle. And the bottom the bottom branch, the final branch, it continuously checks the ultrasonic sensor. And when the ultrasonic detector detects something, it goes up to the true branch, which continuously makes the cloud go up and down to have better pushing power against the opposing robot. My improved version, my version 2.0 of the robot is this. It's much lighter and faster than the other robot. I sacrificed some of the torque for that, but it's much lighter and faster. So they can actually push other robots out of the ring better. Other times it would take a very long time to push other robots out of the ring. So it has less torque. And the front towel on the front is unpowered, which I did because, well, first of all, to make sure it was lighter, make sure it was light enough to move quickly, and second of all, because we're allowed to use three motors.
My improved version still kept the gears, but the gears this time were switched so the wheels would spin fast and not be strong. It was more compacted than our other robot and doesn't really look like a fortress anymore. And I used bigger wheels so we could cover more ground faster. In this robot there were only 2 servos, where in our first robot we had a third motor to lift the plow up.
We didn't progress as fast as we would have liked. One of the main reasons for this was we basically wasted about 2 days working on a forklift, which ended up just not working well enough for us to use. I built the programming and built the main chassis of the robot, while Harrison refined the robot and added improvements such as like the shield protecting the sides of the wheels and added more stability to the robot. And we decided ahead of time on the design of the robot to avoid conflict.
During this project, we learned how to modify the gears for more torque rather than speed. And we learned how to program it with different branches for parallel processing.
We also learned how to program an algorithm for finding another robot. We used a couple different ones. The one we used for the original robot was to just turn until the ultrasonic sensor sees something where it moves forward. But for this robot, I did something slightly different. What it does is it turns for a certain amount of time, and after that amount of time, it turns the other direction, so that because often 2 robots would get kind of locked in like a ring around rosy, where they were both turning right around each other and they were locked together, never detecting each other. So to fix that, I did this where it will turn different directions. And I got help from Miss Wolf for doing that, because programming that involved including lots of variables and logic gates, which I didn't have much experience. So I had a lot of help from Miss Wolf to figure out how to do that.
We enjoyed this project a lot, and we thought that it was much more competitive than other projects, because in this project we were actually going against other teams. And it required a lot more experimenting and smaller goals, so we could move step by step to create a final version of our robot.
Any questions?
It's a funny slide.